But yeah, in the long run, they're just things that are not necessarily needed in there. And it's going to end up, if you get too fancy, you're going to end up just costing the company a lot more money. So you always have to think about fit, form, and function. Okay. Those are kind of the big keys. And anything above and beyond that is kind of flatter.
Growing a business requires a holistic approach that extends beyond sales and marketing. This approach needs alignment among people, processes, and technologies. So if you're a business owner, operations, or finance leader looking to learn growth strategies from your peers and competitors, you're tuned into the right podcast. Welcome to the WBS Podcast, where scalable growth using business systems is our number one priority. Now, here is your host, Sam Gupta.
Hey everyone, welcome back to another episode of the WBS Podcast. I'm Sam Gupta, your host and principal consultant at digital transformation consulting firm Elevate IQ. A machine is not a microwave where you can throw a piece of steel, push a bunch of buttons, and expect your parts to be done. The inner workings of machines are fundamental to be able to program cost effectively. You need to take several things into account, starting from the fit between materials and machines. You also need to figure out the appropriate setup times to make sure that you can make the part in the budgeted amount. In today's episode, we have our guest, Jennifer Bannink Bloomer, who discusses how machines think and why that matters to the machine shops. She also discusses why comprehensive understanding of materials, machines, and their applications is essential for making parts. Finally, she shares several stories about cross-functional collaboration between machinists and engineering departments that require open and transparent communication. Let me introduce Jennifer to you. An advocate for trades, Jennifer truly loves the versatility and constant change of working in the tool and die industry as a pre-sales engineer and serving customers with their machine needs in various industries. She enjoys coaching her customers on how to take advantage of modern trends in the machining industry and is very passionate about machining and manufacturing. With that, let's get to the conversation. Hello, Jenny. Welcome to the show.
Hello, Sam. Thanks for having me.
Of course, my pleasure. And I am super excited to dig into your machining background and how to think like a machinist. But before we do that, just to get things off, do you want to start with your personal story and your current focus, Jenny?
Sure, I absolutely would love to. So I'm currently working for Tormach as one of their technical pre-sales engineers, but this is not how I started out. I originally started out as a farm kid. I grew up in northwestern Wisconsin on a dairy farm. When I graduated high school, I went to college originally for journalism because I enjoyed writing, but I kind of found it a little bit bland after a bit. I really missed being out in the shop. When I was growing up, I used to go help my dad fix tractors. We would go to auctions together. He'd buy me old broken down Briggs & Stratton motors, and he would have me fix them. That was just kind of a hobby. It was kind of something to keep me out of trouble. And I really missed that spark, that moment when all of a sudden you fix something, you make something, and you're like, aha, this is it. This is mine. I did this. And so I went into the workforce for a bit, started out with actually on CNC with lasers at a little company called Laser Machining in northern Wisconsin. So I found myself absolutely fascinated with CNC equipment because there were so many moving components and there were so many things to fix and to learn and to understand. And so I always had that natural curiosity about how things worked, and they allowed me to kind of dig into some of the equipment, really learn and understand how all the mechanicals work together. And throughout the years, I did do different jobs, office jobs. I just found that there was no joy for me in a cubicle. And so after the economy kind of got bumpy in the 2006, 2008, there was a layoff at one of the laser companies that I was working for, which was Northern Metal Fab. And I decided at that moment, I'm going back to school. I was a single mom at the time, and I walked over to WITC near Richmond and applied as a student there. I was a little nervous because part of the component was a math test, and I always hated math. I found out I was actually very good at math. And so I went to school. It was two of the best years of my life and also two of the hardest years of my life. I was working full time and going to school full time. I started working at a little company, a tool and die shop, my first semester. And it was fantastic. I loved it. I loved tool making. I fell in love with it because there was something about making this large, complicated, very precise 3D puzzle. And there were so many different machines to learn.
Okay, amazing background there. And I really love your energy and passion for machines. And once you actually work in the real world, you will not find the journalism very exciting. So I definitely love your background. So we have one of the standard questions that we ask. So before we dig into your background, the question is going to be your perspective on business growth, Jenny. What comes to mind when you think of word growth?
When I think of growth, I actually think of you're not just growing this company, you're growing the people within the company. I think honestly, for any company to be successful, you have to make sure, just like a machine, you have to make sure that all the moving parts are in sync. I think there's a lot of the times companies struggle because they compartmentalize. So you have the engineers versus the machinist, the, white collar workers versus the blue collar workers. And I think that a company moves better when everybody understands each other's their functions, their job responsibilities. I think that popping the bubble is the way for any company to move forward.
Okay, amazing insight there. So now let's talk about the different kind of machines, the comment that you mentioned that there are different kind of machines, and for each product situation, there are probably going to be different machines that are going to be applicable. So now let's talk about some of the executives. Let's say if they might not have as much background in the machines and they just don't know how to basically work on the newer CNC machines. So can you describe the different kind of machines that are available in the market at this point of time? And what do they need to know based on the products that they might be manufacturing?
Oh, sure. So just like anything that you're doing, you have to have the right tool for the job. And that's where things get really, in order to be cost effective, you need to use the correct machine. So there's CNC mills and there's there are so many different flavors of it. Typically a 3-axis is the most standard, where you have an X, Y, and Z with a moving spindle. But then there's also rotary axis that you can put on there where it's turning while it's machining, as well as 5-axis, which is awesome. They're pricey, but they're awesome for having for simplifying your setups and for machining areas you wouldn't otherwise be able to machine. And then of course we have lathes, which is basically like a mill tipped on its side with only 2 axes, where the workpiece is actually turning and the tool stays stationary or moves along the axes. And then you have 2 other things that a lot of people don't typically see unless you're working in a mold shop or where they do precision machining, but you do have electronic discharge machines, wires and sinkers. These are fantastic for details that you wouldn't otherwise be able to machine with a conventional machine, because you're able to shape an electrode that goes in, or, you also have the wire and it actually burns instead of cuts away the material. The thing with EDM, they are amazing, but they are relatively slow. You usually, when you send a job into the EDM, it's going to be more expensive. We also have plasmas, kind of like, how do you describe plasma? Plasma is actually the 4th state of matter. So you're actually cutting through the material. Again, it's very similar to like a laser, different inner workings, but then you got your saws, your routers. A router is generally going to be more for woods, plastics, the softer materials, because they don't have the rigidity of a large mill. And grinders, one of my absolute favorites, for real precision work. So, if you want something extremely flat, you're going to slap her on the magnet, you're going to grinder, and it's a lot of measuring, it's a lot of rinky dinky work, but you kind of almost get into the Zen-like feel when you're behind the wheel. So those are kind of most of the ones that you're going to see on a regular basis.
Yeah. Your comment about, right tool for the right job. And you did mention that, the machines could be expensive if you are utilizing the machines in the cost effective manner. So obviously, let's say if you are not doing precision work and if you are going to utilize a machine that is designed for precision work, most likely you are wasting your money just because that is not designed for the job. And I don't know how good the job it is going to do. So let's say, again,
if the executives are looking at more of different products. So right now we spoke about different machines, but let's say if we look at different kind of products that they might be building. So can you take one example of a product that is going to be appropriate for each of these machine types?
So a lot of it has to do with the setup. So I mean, you can make here's a really good one. So
Yeah.
like when you're making a mold, people
Yeah.
are like, well, wouldn't it be just simpler, since you want it precision, to make a big
Yeah.
giant electrode and burn that in there? So you're taking a piece of graphite and burning it into the machine. Well, and remember I talked about that being a slow process.
Yeah.
So like cavity work, core work would be more suitable for like a mill. If you're doing round work or gear, you can make a gear in a mill. It's going to be a very long process though, because you're cutting away the material and you have to go in and carve out the geometry for every individual tooth with one spinning cutting tool. The appropriate machine for like a gear would actually be a hob and a shave.
Yeah.
Those are different machines that they're using in the gear industry. So instead of an end mill, you have like a corn cob looking cutter that goes in there and cuts the gear tooth. And the cutter actually has the profile of the gear root that you're wanting to be cutting. So you could look at it and say, well, we have this mill that you could be using for more intricate work. And so if you're cutting gears in the mill, you're actually taking out time from other jobs that you could be utilizing that particular machine for. A lot of it's about diversity, and it also depends on the industry you're in. If you're in a job shop,
Yeah.
You're not going to put a tiny part in a large mill unless you really absolutely have to. Because machine time, every minute on that clock is time that you could be making chips, making money for the company. And so it's very important too, when you're designing something, to understand what machine it's going into. And that's where I was talking about the pop the bubble. A lot of the times engineers don't have the hands-on machining experience.
Yeah.
And so opening a dialogue up with the machine shop's really important, asking for recommendations. How should I design this? I see the biggest mistake I see a lot of companies make, and it's a very costly one, is they keep those two departments separate. And so an engineer doesn't really understand, hey, if I design this so that we're burning all of this, or I put a sharp corner in this, that can be incredibly costly because you're wasting the machinist time, because you have to look at how many setups for a job. If you're making a gear, you're going to have to, in a mill, you're going to have at least 2 setups because you're going to have to flip it on its back. So you got to, mill side 1, mill side 2. You got to think about your machinist time as an asset. You got to, also think about the machine time as an asset. I have a really fun story if you want to hear it about how I made a $600 washer. So, because I think a lot of the times people view the machines as an asset, but not the machinist time. And the machinist time is actually your most valuable asset, because that machine's not going to do anything without your machinist. So I was working weekend shift for a company, and I had someone come in from the maintenance department, and I was doing mold repair, CNC programming, and setting up the machines and running. So we were kind of a skeleton crew, and the interdepartment cost was right around like $300 an hour for my time, for either programming, my machine time. And he came in and he goes, I need this part. And he gives me a drawing that he had made on the back of a napkin. And I said, oh, you need a washer. And he's like, well, no, I need you to make me this part. And I looked at him and I'm like, well, I could just get you a washer. I got plenty of them in my toolbox and I have them the exact same dimensions. And he's like, no, you're not understanding. I need you to program and make this. So I said, all right, well, sign off. We'll sign off on this together. And because at the time we were using an ERP system to kind of throw our stuff in there, and I had to get signed off on a job. It's kind of one of those CYA things. And so I made him the washer. It didn't take long, but between programming time and machining time and getting everything set up, getting the material prepped, it was about a 2-hour job. His boss came in the next day and he goes, why did you make this? And I'm like, because I was asked to make it. And he goes, and he's like, it says in the notes you offered him a washer. I said, I did. And he goes, you should have made him take the washer. And I said, well, my job's not to question it. So when you're looking at that kind of stuff, as far as machinist time and the actual appropriateness of the machine, there's so many moving parts. You want to make sure that you're, putting your job in the right machine. You want to also make sure that you're respectful of, the company's time, the machinist time, and the machine time itself.
Yeah. So very interesting story. So let's talk about this disconnect. I mean, obviously it is going to be about the communication. And I think we discussed this in the pre-show as well, Jenny, that when it comes to communicating and understanding how machine thinks how machinist thinks, that could be a little bit of work, especially for engineers, as you mentioned, that they don't necessarily have the hands-on experience. What other stories that you might be able to share when you look at the design and you sort of know that the engineer does not really have the hands-on experience, they don't necessarily understand how machines think or work? Do you have more stories that you might be able to share about this overall disconnect from the real world?
Oh boy, do I ever. I have several, but so as a machinist, part of your job is to understand metallurgy. I think a lot of people think, a lot of your focus is just running the machine, put the part in, hit the button, and there's so many different facets to machining. So in mold making, you cut usually, depending on what kind of mold, if it's a high production mold or a prototype mold, you actually go in there and you're cutting metal and then you're sending it to heat treat. So you're cutting it, they call it cutting it in soft. So you go in there and you rough out the majority of the material, then you send it to heat treater, which is going to give that mold extra strength. And then you bring it back and you do the finished machining. Well, the big thing with, any material that goes to heat treat, you have to be really mindful about sharp corners, pockets. That weakens the steel. As you're making the steel harder, you're making it more brittle. I did have an engineer once come and bring me a print and he goes, I want this made. And I said, well, we need to remove these sharp corners. And he's like, no, I need you to make it the way I designed. Okay. And I said, but you know what could happen? And he was like, what? And I'm like, this thing could break in half. It could shatter and heat treat. And I was told, nope, just do it the way I designed it. It did come back and there was a crack all the way through that core. And we had to go ahead and start from scratch all over again. Just one simple little, not understanding the material and not understanding what features can weaken the part and what features are assets to the part. Other common mistakes I've seen, and I've seen these multiple times, is over tolerancing. That is going to get you every time. So if you're doing like an ejector plate or something that has like clearance, counter bore for a socket head cap screw, like when you're putting together your IKEA furniture, you got the little pocket so that the bolt sits below flush. Do you know what I'm talking about? So when you're putting anything together, I have had more prints come back where they have that called out as plus or minus 1/10, which is 0.0001. Or 0.0001. And I've brought it back and said, hey, there's no reason to over tolerance this. And, have been told, well, no, do it the way I made it. And I'm like, okay, but it's going to be more expensive because now when you have a tolerance that tight, you're constantly measuring and measuring and remeasuring, trying to hit those numbers. When all that pocket serves as a function to recess the screw. So you spend all this time dinking around with something that is not even a critical feature. So that's a huge, and I think a lot of people don't realize how much of this actually goes on in their shop where you're over tolerancing. Or the other common mistake I've seen is adding features that are more difficult to machine that add no value to the product. So, it's really easy when you're in there designing something to get really carried away with extra features, extra radiuses, cute little splines here and there. But if they don't serve a purpose, they're costing your company money. So I think it's extremely valuable for machinists to understand engineers and engineers to understand machinists, what's important, what's not. Because if you're machining something that isn't important or isn't a vital part of the component, you're just wasting, again, machine time and the machinist time and your company's money.
Yeah, I love the way you think. Obviously, you are extremely passionate about machine, but you think like a CFO. So that's what our community is going to appreciate. Okay, so when you are talking about these extra features, they don't really add much value from the machine's perspective. Can you provide some examples of what are these features that, let's say, if the engineers are listening to this show, what should they know about these features? Provide some examples.
So, if you're doing clearance is important, but you never really you don't need to tolerance clearance. So clearance is kind of like, like when you're driving your car up to a curb and there's a mailbox. The clearance is the amount of room that you leave yourself between the door that you have to open and the mailbox.
Yeah.
It doesn't have to be specific. It just has to be big enough to clear the door. If you park too far into the street, you're going to get hit. If you park too close to the mailbox, you're going to hit the mailbox when you open your door. So, but there's a lot of ample space in between that where you're either over too far to the left or over too far to the right, but it doesn't have to be super precise. When someone tries to get creative, they're trying to make something aesthetically pleasing when it doesn't need to be. You're not going to spend time polishing a mold base unless, with the exception of the parting line, because nobody cares about that. It doesn't serve any function other than housing the mold. And so, you have to be really careful about, I guess, if I really want to describe this in a simple way, is keep the KISS method in mind. And the KISS method is something that I learned when I was in trade school. Keep it simple, stupid. It's really, really easy to get carried away with design. It's really, really easy to get carried away with almost your own ego. Like, look at this really wicked, cool part that I made. Yeah. And it's really great. And chances are you can machine it using multiple machines. But in the long run, they're just things that are not necessarily needed in there. And it's going to end up, if you get too fancy, you're going to end up just costing the company a lot more money. So you always have to think about fit, form, and function. Okay. Those are kind of the big keys. And, anything above and beyond that is kind of clatter.
Right. So let's talk about this notion of super, precision, especially when you are talking about these clearances where, let's say, if you are going to be super precise, it's not really going to add much of the value. But from the programming perspective, when you think like a CNC programmer, right, when you try to create this super precision in a specific job, does that make your job harder? Can you touch a little bit more on that? Why the job is going to be harder? Let's say if you don't have room for negotiation, hey, you are looking for clearance here, and whether I provide you, let's say, quarter of an inch versus, half an inch, it's just a clearance, right? So what is so hard when you don't have ability to negotiate with your engineer?
Well, a lot of the time, if you don't have that ability to negotiate, no matter how much you want to save the company money and no matter how efficient you want to be, it's just throwing in more obstacles. If you're not able to negotiate, if you're not able to sit down and say, look, I can make it as it's drafted out, but it's going to take an extra 2 weeks and it's going to cost, X amount more to run it this way. If you're not able to have that conversation and you just kind of have to make what's in front of you, I want to say it almost kind of affects the morale of the building as well, because then all of a sudden you're in the shop and you're kind of salty at the engineer because the engineer is making you do these things that are not efficient. It's not a good use of your time, and it kind of causes a little bit of animosity. And morale is and I know it sounds cliche, but morale is a very important part, and it's also part of the reason a lot of machinists leave their jobs. Is, if you spend every day saying, okay, I don't feel valued, I don't feel like the recommendations that I make, even though I know they're correct, are not valued by the company, the company could be losing a huge asset, which would be the machinist itself. And so being able to negotiate and sit down and say, okay, let's talk about what is the best use of the company time, the machinist time, and even the engineer's time. You don't want the engineer to waste a lot of time adding features that are not important. I'm seeing a really growing trend right now because I do work with a lot of clients. It's their first machine. A lot of folks buy our equipment at Tormach because they're retraining their engineering group. I've been to multiple companies now where they actually bring a machine in for the engineers to learn how to machine because it makes you a better designer. Design for manufacturing is a really big buzzword right now, and it's a really important word because understanding how to design for manufacturing so you get that smooth transition from your SolidWorks or from your CAD system into the program, into the job shop is going to be key. It streamlines the process, and it's the only way you're going to be able to keep up in industry is having that smooth flow.
Right. So I am actually trying to develop the deeper understanding here overall. I understand that, if your opinion is not considered, then obviously you are not going to be happy or machinists are not going to be happy. But what are some of the challenges that actually causes the job to take, let's say, 2 weeks, just because you are trying to create slightly more precise precision. Is the programming aspect harder? What exactly is a challenge here? Why does it take more time to do that?
Oh, sure, absolutely. So the over tolerancing, and I did mention it's that checking, rechecking, and it depends
Yeah.
too. If you're looking, these are going to be different in a production environment
Yeah.
versus a one-off prototype mold making environment.
Yeah.
So the on the programming aspect, yes, it does make it more complicated. And actually, if you're adding a bunch of extra tools, you're adding to the cycle time of the part as well. And you're also taking away company resources. A good programmer actually has experience in the job shop typically. I mean, I've met programmers who haven't had a lot of experience. You can tell they really struggle with the process of, setup. Because when you're in front of you, the things that take time are, added setup, having to make extra fixturing, and maybe unneeded fixturing. And so you could take a job that, suppose there's an internal feature that's put in there that it doesn't really serve a function. Suppose we're making something that, imagine a donut, if you will, and imagine that there is a little slot cut in the donut. And that slot's not really needed, but the engineer calls it out there and says, hey, we're going to add a slot to this just because, I don't know, it might be cute. It's not a realistic thing, but it's like, and it's like, okay, what is it? Does it serve a function? Well, no, I just want it in there because I did it in there. It's the design. So that's great. So for me to do the donut part, I might chuck it up, throw it in the lathe, do the external profile and bore out the center. But now I'm going to have to tie up a fifth axis machine or a sinker EDM or something that is capable of cutting this detail, which wasn't even needed in the first place. So now you've added multiple steps to something that is not required. And it doesn't serve any value to the end customer. It doesn't serve any value to the company itself. You've just wasted a lot of resources, and now your part's taking longer and it's going to cost more money.
Yeah, that's a very interesting example. So obviously you talk to a lot of different customers. If they are buying the machine for the first time, if they didn't have these machines on their shop floor, I am pretty sure you are going to have some of the interesting stories there as well, because in case of engineer, you might have some room to negotiate because they are part of your company. But in case of customers, sometimes you might not have as much room to negotiate. And especially when you are working with the engineers of customers, it could be even more challenging. So when you work with them, what are some of the interesting stories that you have seen? And obviously you don't have to name the customer. What we are trying to do here is we are trying to learn from our experiences. Obviously they are not going to have as much background in the machine because you do this on a daily basis. So you are going to know far more that either their products are over-engineered or they have just over-engineered the overall design for some reason. I don't know what that reason is. So
right.
What are some of the interesting stories you can tell from the customer's perspective?
Oh, from the customer's perspective. So I came from medical molding is my background. So I've actually had the great pleasure of seeing a lot of waste and a lot of, one of the big things with mold making, and I'm sorry I keep coming back to that because that is kind of my most experiences in mold making, but things like negotiations on, and you wouldn't think anything of this. So when you look at a plastic part, the texturing, I've had clients who I want this whole mold high shine. Yeah. Now, high shine, I don't know how much experience you or your viewers have had with polishing, but polishing is a very long, drawn out process. Most of it's relatively manual. You're usually rubbing with, stones, papers, diamond polish. And so for, let's say I'm polishing something that's 4 inches by 4 inches, and this is flat. We won't do any detail. If I'm going for a high shine, that 4 inch by 4 inch part is probably going to take me roughly overall, probably 6 hours because there's so many grits you have to go through. And so sitting down and explaining to a customer, and the customer's like, well, I just really like how that looked. Does it serve a feature or function? Well, no, not really. It's like, then you have to have that tough conversation saying, I know you want this, but I typically like to be very tactical when I'm dealing with my customers and sit down and be very outright and very honest. And I can say, look, if it's not a necessity, I would drop it and I like to talk in terms of cost and time. if we drop this feature. So being able to sit down with them and just being honest. I think sometimes we try too hard to we don't want to hurt people's feelings. But I think, you're doing your customer a great service if you sit them down and kind of explain why this is going to cost what it is just for that one feature that they think they need, but they don't really need. Being able to sit down and be honest with a customer, I think, is really important. So what I like to do is, in terms of time, sit down and say, okay, if we do it this way, it's going to cost this much more and it's going to take this much longer, and depending on if they're in a deadline or not. Most people, they always need stuff yesterday. But sitting down and saying, hey, this little feature, if we were to just to add, if we were just to polish it to this instead of high shine, this is how much we can save you, and you're not going to need that high shine finish.
That's a very interesting story, and I think a lot of people can learn from it that even though you might want high shine, unless that is coming from the consumer's demand or that serves some sort of feature, then only you want to have that. Otherwise, you are unnecessarily going to make your part expensive. So one of the things that we were discussing about this overall aspect of thinking like a machine, and you do think like a machine, you can tell by talking to you that obviously you are very experienced and you are really passionate about this as well. But the people, let's say, if they don't have as much experience with the machine, or the customers who might be buying the machine for the first time and they just don't know how to think like a machine, maybe they didn't grow up in the machine environment, and all of a sudden, it's a challenge for them because they just cannot think like a machine. So what are some of the things that you can tell from the machine's perspective, how machines think?
So I've got to say, hands down, coming to Tormach, I worked in technical support where I actually troubleshot machines, got to really understand the inner workings of machines, and it has made me an even better machinist. There are things that, thinking like a machine is very valuable because you have to understand a few things. The machine does not have eyes. It does not have ears. It does not have artificial intelligence. Maybe someday, but right now, not so much. Your machine. So the biggest trapping I see, especially with new machinists and everything, is blaming the machine when something goes wrong. Well, the machine decided to do X. The machine decided to do Y. And the thing that it's really hard to break people of is the machine didn't make any decisions. The machinist behind the machine made the decision. So if your machine crashed, and don't get me wrong, there are some things with anything electronic, things can go wonky, but understanding your machine and thinking like the machine's going to. So when you start out machining, a lot of the times you start on a manual machine. And I know people are trying to do away with this, get rid of the manual machine. It's not needed anymore. CNC is the way to do it. But I love it because when you're behind a machine, you actually can feel what the machine's feeling. I'm not talking in terms of like feelings. I'm talking vibration, smell, sight, sounds. You can feel the pull of the tool. Understanding how all the pieces work make you a better programmer, make you a better designer, make you a better machinist. Because when you understand, so you're standing behind the control. I like to tell people this. So this is how a machine actually works in a very, very simple manner. CNC, computer numerical control. You stand behind a control and you tell the machine, hey, machine, I'm going to make this part. In order to make this part, and your program's doing this in the code. So this is a real pared back way, but you tell the machine, I want you to move 3 inches in X, which is to the left or the right. I need you to move a half an inch in Y. The controller then tells what's called stepper drivers, and the stepper drivers that live in the machine, they receive the signal. Then they convey that signal to the motors, whether they're stepper motors, servo motors, and then the servo motors actually make the ball screw turn and make the table move. Once you understand that, you can understand that everything that you're putting in the machine, you're telling the machine what to do, and you can start to see and hear, like if all of a sudden you're bogging the machine down, you can hear the machine grinding. So you're like, okay, I got to back off a little bit. So because a machine's not a microwave, a CNC is not a microwave. I love to tell people that. I think a lot of people assume you throw a piece of steel in there, you just hit a couple buttons and you hit go. There are so many things, and the machinist thinks like the machine in terms of, okay, what's going to be the effect if I am diving into this pocket with the end mill versus ramping in? I mean, what's going to be the effect on the machine? You can hear things grinding. You can hear the spindle bearings really working. understanding and being able to respond to your machine is really, really important, because it helps you prevent like skipping steps or overworking the machine, or understanding that, hey, I have to take a spring pass here. And how you're almost kind of predicting what's going to happen based off the experience you have, but then understanding how your machine works. A lot of the other issues that I see with people is not, each machine's going to run slightly different. So a lot of the times that I'm standing behind a machine, I'll look at it and say, oh, I know this. I like to name my machines. I have Trixie, I've had Tallulah. You go out there and it's like, okay, Tallulah has a little bit of slop in her ball screw. I happen to know that she has, 0.8 a backlash. All backlash is, people overcomplicate backlash. All backlash is if you were to take a nut, put it on a bolt, wiggle the bolt, that's backlash. That little bit of play in there, that's all that is, because under the machine you have these ball screws that turn, which move the machine. Okay. So to make a good part, you're going in there and you realize that the machine might drift a little to the left or right. So you program and you set up and you machine accordingly. So understanding your machine is really important, because not all machines are the same, and you don't just drop a piece of steel in there and hit a button and expect it to be perfect.
So that's it for today, Jenny. Do you have any last minute closing thoughts?
So many things to say. So I guess my closing words would actually be probably my credo, because people ask, what does a machinist do? A machinist finds a way or makes one. And the Latin term for that is ad inventium viam ad faciem. And basically I think that, from the CEO, the CFO, down to the machinist and the engineer, I think it's really important that you work together as a team and realize that, if one solution doesn't work, working together and finding that solution is going to help make your team more profitable in the end. So.
Amazing. And my personal takeaway from this conversation is going to be, if you really want the results from the machine, you have to think like a machine, and you have to figure out how to work with the machinist, because they are the ones who are really making things on the shop floor, and also for the machinist. If you really want to be productive, if you want to save money for your company, then you need to open up, and you need to be able to communicate with your superiors. You need to be able to communicate your concerns with your engineers. And the more open and transparent you are in your communication, the better you are going to be as a team, as a company. On that note, Jenny, I really want to thank you for your time. This has been an insightful episode.
Oh, thank you, Sam. I really appreciate it. I had a blast.
I cannot thank our guests enough for coming on the show, for sharing their knowledge and journey. I always pick up learnings from our guests, and hopefully you learned something new today. If you want to learn more about Jenny, head over to tormach.com. It's TORMACH.com. Links and more information will also be available in the show notes. If anything in this podcast resonated with you and your business, you might want to check other related episodes, including the interview with Martin Davis, who discusses these strategies to improve your manufacturing facilities capacity and increase the overall equipment effectiveness of your equipment. Also, the interview with Matt Goosey from MRS Machining, who discusses the challenges associated with manufacturing complex parts in short runs. Also, don't forget to subscribe and spread the word among folks with similar backgrounds. If you have any questions or comments about the show, please review and rate us on your favorite podcasting platform, or DM me on any social channels. I'll try my best to respond personally and make sure you get help. Thank you, and I hope to catch you on the next episode of the WBS Podcast.
Thank you for listening to another episode of the WBS Podcast. Be sure to subscribe on your favorite podcasting platform so you never miss an episode. For more information on growth strategies for SMBs using ERP and digital transformation, check out our community at WBS.rocks. We'll see you next time.